Hey everyone, in today's video we're going to take a look at this Pioneer SA-900. This one showed up locally and the issue is that it is blowing fuses out of the power amp. So could be a bad output transistor, could be something else. We're not exactly sure yet. We definitely need to take a look inside of here and see what's going on. One thing that's kind of unique about this one is that this was brought to me by somebody that already attempted to fix it themselves and they were unsuccessful. So we're going to take a look here and see what we find and see if we can get this thing working once again. Yes, it is a beautiful day here in Montana today. Let's take a nice look at this receiver. Sorry, integrated amplifier. It's in quite remarkable condition. And this is also going to be the oldest piece of Pioneer gear that I've ever worked on. I've only ever worked on like the mid-70s stuff. This is going to be early 70s, so some of the first solid state stuff that Pioneer ever made. You can even see there's a little bit older of their label right there. It's a pretty basic integrated amp, but it's got some unique things. You've got bass and treble control for each channel, which is not common. Then you got this big giant knob for your mode, so like you can reverse your left and right channels if you want, or you can put it in just the left, just the right, or left plus right, aka mono. And then of course we've got plenty of inputs on this thing. Two phonos. We've got the tape head. Never really seen it say tape head before. That's interesting. Then you got a microphone input, which is right there. Down here, pretty basic. Low, high filter, loudness button, muting, balance, speaker switch. And then here's your power switch right here. It is a knob. I don't really like this style of switch. I'd rather have the toggle switch like right here, but they got that sorted in the later models like my SA-900. What do you think, Sadie? You gonna get the birds? It's in quite good cosmetic condition, and yeah, I do plan to get a table here, but I was actually going to go buy a table for this in town, but they don't have one that suits my needs, aka is adjustable and taller, you know? So here's the back, here's all those inputs and stuff. What does this paper thing say? When using these terminals, remove these plugs. Okay. If I want to use those terminals, I'll be sure to remove those plugs. In fact, I'm not exactly sure how you would use these terminals with those plugs in place, so makes sense. Then, of course, we've got our classic old Pioneer thing right here. They tried to get you to buy their proprietary speaker connectors, or their speakers might have had a wire coming right out of them that have this like weird little thing. Not exactly sure how we're going to change that. I know I can just jump inside and get my speaker output by running some jumper cables, but we'll see what we want to do in the future here. And of course we got somebody's social security number engraved very sloppily. What's your social security number, Sadie? Do you have one? Come here, big guy. Come here. Come be part of the video. Let's have fun. So yeah, I mean, we're all having a great time out here, but unfortunately, I think we gotta move inside. I think the last thing I'll do out here is get the cover taken off, and then we'll be able to see inside real nice. Looks like we gotta use a flathead here, and then we can take the rest out with our fingers. And if I drop this hardware, it's gonna go through the deck and it'll never come back again, so I gotta be a little careful here. Okay, we're missing the washer on this one. And maybe once I get this table, we can actually record something getting repaired out here. But until then, let's just take a look at what we've got here. So right off the bat, you can kind of tell it's going to be a capacitor coupled amplifier because you've got your two big caps right here that will act as your coupling capacitors for your output. And then this is a nice big one right here, 100 volt, 3300 microfarad. Not sure what this one here is for. Maybe the power supply. Interesting to see some pretty high voltages here, actually. Normally you don't see stuff this high in solid state gear of this vintage. But I can already see one thing that is going to be a problem. And I knew this going in. We are missing some output transistors here. There's the two on this channel, but we got nothing over here. So that was part of the attempted repair, and we're gonna go inside now and see if we can see why we're blowing fuses, which also, let me just point out real quick. We have fuses right here coming off of our, I mean, this wire is probably the positive rail off of this thing. And then it gets split into these fuses, and then you got one going into each channel. So if you've got a short on one channel, it's going to pop these fuses, which is really nice for troubleshooting. You know exactly what channel to look at, and if one of these is popped and it's not working, well, your issue is obviously in the power amplifier. So I'm looking forward to diving into this thing. We'll see what we find. Alright, so first things first, we've been given some presents, and those are the output transistors from that channel that is blowing fuses. So let's go ahead and throw these on the transistor tester and see what we get. And this will tell us pretty quickly if we've got any shorts in these transistors. So the collector on a TO3 like this is the case. So let's just test this. Short circuit on red-green, so there you go. Bad output, that will definitely blow a fuse. Now, let's check the other one, and this one is okay. And it's reading as a germanium transistor, which, a gain of 6, interesting. Huh. I'll keep that in mind as I go through this. I haven't done too much research on the SA-900 just yet. And these transistors say Morse on them. USA transistors, so that tells me that they are probably not original, because this is very much so a Japanese amplifier. Let's see, and then yeah, in here we've got Sankins, and they are the same transistor, and these two right here, it says they're the same transistor, but they're marked completely differently. Maybe you can see that. One has white text, one has black text, and one is 90 degrees clocked different than the other. So I don't know what's up with that. That's kind of interesting. I'll bet you that thing is reading as a germanium because it's probably messed up. Let's go ahead and check these fuses that I hear are giving us trouble. We have a good fuse in the left channel, and then in the right channel we have another good fuse. So great, good stuff there. And might as well just throw this on the dim bulb for funsies, because I'm curious to see what exactly it does after not looking at anything. Fun fact, I just got a clear bulb for my dim bulb, which is going to be much better for what we're doing here, because instead of having the clouded glass, you can actually see the filament in there very clearly. So that's going to give you a more accurate representation, or you'll be able to see in finer detail. Like if this was super dim, I can actually see that filament lighting up, whereas before the clouded glass would keep me from seeing that. So I'll turn the dim bulb on, and let's go ahead and turn the amp on right now. Very interesting. Very, very interesting. So as you can see, we've got some pulsing actually on the dim bulb. Very bizarre. Yeah, I think it's time to start tearing this thing apart, and we'll see what the heck is going on here. Let's pull the bottom cover and see what's going on under there. So what's in here? We've got 2 filter capacitors, probably for 2 separate parts of the power supply. I'm going to test each one of those just to make sure they're okay. Looks like this is probably a preamplifier, and then this is the bottom of the power amplifier board here. And we've got our little temperature sensing diodes there. So we'll just test our big capacitors real quick. And fun fact about this meter is it actually will discharge the capacitor also. Looks like it didn't need to do that. This is supposed to be 3300. We're at 3400. That's great. ESR pretty low. Very good. Our smaller one, what do we have? 578. I Oh yeah, that's 470. So a little high, but nothing I'm terribly worried about at this time. They're not shorted, which is a good thing. I'm also going to test the coupling capacitors, make sure they're okay. This one here, whoops, it's supposed to be 2200, and it is 2200. ESR is a little high for something this big, but I don't know. And over here, what do we got? 2200. Okay, so that ESR is 0.05? Yeah, this thing's ESR is like 9 times higher. I wonder if there's a resistor somewhere across this that's causing that, but I don't think so, because it should be the same circuit. That's something I want to think about as we go through these. One of these has a much higher ESR than the other. That's odd to me. Might need to build ourselves one of those difference amplifiers that X-Ray Tony B just built himself. How the heck do you get these out? I would like to look at the power amplifier board and check all of its transistors to make sure everything's okay. I'm not too sure how we're going to do that just yet. One thing I was told about was we're missing an insulator on the output transistor mount. And maybe I have something laying around, I'm not too sure. Shoot, where did that go? I think it went on the floor somewhere. And of course, it's the color of my carpet. Great. Great. Oh, found it. Perfect. Yeah, so one thing I was told is we are missing one of these little insulators here. And that would definitely cause an output transistor to short out. So I have, oh, what is it? I bought some parts thing years ago, and I just have a random collection of thingies like this. Let's see if there's one in here that's similar enough to this, and maybe it'll be able to take its place. Oh, would you look at that? This looks quite similar. I think we've got a winner. Okay, so the outputs here, they are 2SC, which means they're NPN. So I need to go find some NPNs. Alright, we got some replacements here. So I'm just going to get real lazy here real quick and just replace the outputs. I'm going to put 2 known good outputs in this thing, throw it on the dim bulb, and see what happens, because I don't think I have too much to lose here. Okay, so I've got this thing kind of haphazardly set up here. We have outputs in all of them. I only have 1 screw in, but we still have full electrical whatever. And then this is held in by 1 screw right now. But I'm curious. I want to see what happens when we've got 4 outputs in this thing. Okay, we still pulse. So, very fun. Let's see if we get that pulsing when we have the left channel fuse in. We don't. And since we have transistors in the left channel, in theory, we should get sound out of the left channel. So let's take a look at that. We'll have to connect to the speaker with jumpers, because Pioneer. Alright, so I've got everyone's favorite song playing. Let's get us set to A speakers, which we are. Let's get set to aux 1, which we are. Do we have sound? Oh, that's because I still haven't hooked up the speaker. Oh, we got something going on there. Alright, so there you go. Left channel's working. So we're probably getting that pulsing out of the right channel because of probably a shorted output transistor. Yeah, watch this. Woo! Yep, don't like that. So let's pull the transistors on the right channel and see what happens. turn on with outputs removed. Seems to work. So that's interesting. Let's turn off and let's test right side output transistors. What will we get? What will we get? What will we get when we test the transistor? We will get good. And this one reads as a silicon transistor. Now, what does this one read as? Ooh, the plot thickens. Both good transistors. This one's gain is way lower though. Very low gain. So that's interesting. Why would it work with the outputs removed, but not with the outputs installed? That's a question. Putting new 1194s in the other ones seem to fix the problem, so let's try that with this one. We've got brand new MJ21194 transistors. Okay, new outputs are in. I would expect this to not work, so let's see what happens. Yeah, exactly. So there's something else going on in here. I've found a surprise. Let's take a nice close look in here. I'll do my best to show you. But there is a resistor that should probably not be in the amp anymore. So there's a resistor right under that silver transistor. That is black, and it's not exactly the easiest for this camera to focus in on that. Yeah, we're going to look up what resistor that is and see if we can get a replacement in there. As I'm removing this resistor, it is already in two pieces. So here's piece number 1, and let's see if we can get piece number 2. Yep, there's piece number 2. So that's not cool. Yes, it is a 1/4 watt resistor. So I've got this pack. This is just something I got on Amazon a long time ago. Actually, no, I got it recently. And would you look at that? We've got ourselves 18 ohm resistors. So we need, what did we need? We needed the brown, gray, black. And let's just double check to make sure it is indeed 18 ohms. And it is. Hopefully you can see that. So let's throw that in and see if that changes anything in terms of our amplifier's behavior. Okay, so that was R27 or 28 that had completely burned it up here. Can't use that. That's I don't recommend you use resistors like that in your amplifiers. So let's again see if we get any different behavior. When we turn this on, we do not. So that's kind of interesting. I wonder what is causing all this trouble. Maybe we can look at the schematic and see why would that resistor do that? What would cause that resistor to fail like it did? So it looks like R27 is in the vicinity of the bias circuit. So I wonder if maybe we've got a bad potentiometer on our hands here. So what I'm going to do real quick is turn it back on. You know, we see we've got our issues. Now I'm going to try to turn that potentiometer and see what happens when I turn it. I wonder if anything will happen. Nothing happens. Let's check the nearby transistor for shorts also. That could be it. Okay, I found something else. The transistor that you saw next to that cooked resistor, I pulled that one out because I thought, something else is still shorting on this thing. and when we test it, short circuit on red green. This is a 2SA-484. So we just replaced R28, and R28 is connected to the emitter of Q8, which is a 2SA-484, so we have a shorted driver transistor? I think that's a driver transistor for the output. So let's find a suitable replacement for 2SA-484. Alright, let's have fun. Let's be reckless and let's go ahead and replace this transistor with the first thing that Google came up with an Audio Karma forum saying, "Yeah, try this. It might work." And that's going to be KSA-940. Obviously, the KSA-940 is a TO-220 style, which is a little different than whatever the heck this is, but I don't know, maybe it'll work. Let's make sure we get the pin out right. The board's marked top and bottom. It's base collector emitter. Okay, that was a struggle, but we're there. We have the outputs in, we have this thing taken out, we have that resistor replaced, the bias pot's back in, both fuses are in. I'll turn the power on and then we'll turn the dim bulb on and see if we still get a bright bulb. What's going to happen? No bright bulb. Alright then. So then the question becomes, do we have sound out of both channels? Let's hook our speaker back up. Okay, that's the left channel. Now let's try the right channel. It works. So this thing has been repaired. Ish. We know it's fully working now, so that's pretty cool. Alright, it's been quite a while actually since I've recorded on this last, so let's just kind of review what happened, because as I'm editing this video it's not very clear. What happened is the customer found these to be shorted. These are the output transistors, and I'll pull up the schematic on the screen so we can all look at it and kind of understand what exactly is going on. You can blow these up by being abusive or making terrible mistakes, running too much through your speakers, and these will generally take the brunt of that. Unfortunately, there were some other things that were taken out in whatever happened to this thing. The first thing we'll talk about is this broken resistor that you see next to that other transistor. That is R28. It is an 18 ohm resistor on the amp board, and it was connected to the emitter of this transistor, Q8, which was a 2SA-484. We found that replacing the output transistors did not fix the short. We found that replacing that visually burnt up resistor did not fix the short, as I would expect, because it's just an open resistor. And then this transistor right here is actually what was shorting straight to ground from the power. So now that we've replaced those things, we have proper outputs, we have a proper replacement for the driver transistor and an actual resistor that's not open, we actually get music out of this thing. So, everybody's favorite song. If I turn the balance to the left, I get the left. If I turn the balance to the right, I get the right. And it sounds pretty good. So we are actually in quite good condition here. But we are still on the dim bulb, and since we're in this area, we need to do a few things to this amplifier to bring it up to speed, bring it up to the modern times. First thing, an issue that I can't really hear, but I saw through testing with my capacitor meter, is the coupling capacitors. We saw one had an ESR 9 times the other one. So I bought 2 new coupling capacitors. These are what somebody on Audio Karma used before. These are Nichicon Gold Tune 2200 microfarad 50 volt, just like what's in here. And unfortunately, I gave this the benefit of the doubt and did not check the diameter of these capacitors. They are too small, so I'm going to have to do something to make those fit. What I've done in the past is I've taken like silicone rubber sheet, just kind of wrapped it around so it fits in the clamp, but I really don't like doing that, and I like to size things to the proper diameter whenever I can. But this is probably the right capacitor for the job electrically, so that's a good thing. Other things, if you read the forums on this on Audio Karma, I'll try to remember to put a link to the forum in the description if you're running into this too. There is a balance potentiometer for getting some voltages right for setting this thing properly. Not the bias, but something else related to it being capacitor coupled. And then new bias pots too, because the potentiometers on this thing, I guess they're kind of finicky. And then while we're on this board, we're just going to recap it, because why not? And then I might replace the transistor on the other side with another SA-900, so we have matching things on both sides of this thing. And then we can't run this thing hard because I still haven't applied thermal compound to the output transistors. So we definitely need to do that also. So yeah, that is what's coming up in the rest of this video. I gotta say, I think this is probably the least least technician friendly mechanical design on an amplifier that I've encountered, which saddens me as a mechanical engineer, but I sympathize because this was all very new at the time. You know, solid state in the early 70s. They were just figuring it out, so I don't know, can't be too harsh on them, but I can say this: Pioneer really got it right in their later stuff. Very easy to work on. Alright, so here's what's going on here. I looked at all the caps on this board, and I looked at how they all are in the schematic. And here's what I came up with. I'll put the schematic on the screen. It's worth noting that the E2, E4 stuff, that's basically just ground. For whatever reason, that's how it is in the schematic. So when I look at these schematics, I try to determine whether it's related to the audio circuit or if it's related to the power circuit of the board, basically. So giveaways for power is one, if it's coming right off of the main filter cap, so that'd be B+ on this board, this schematic, or if it's going straight to ground, because obviously your audio signal doesn't go straight to ground. That's probably related to power then. But if it's a capacitor in like some weird place between like two resistors, or like coming right off of a transistor going into something else that isn't ground, it's likely related to the audio circuit. So long story short, there are 3 different 100 microfarad capacitors on this board. The first and biggest one is the 100 microfarad 50 volt. That'll be an Ichicon PW replacement. Then there's some 125 volts. That'll be an Ichicon PW. And then there's a little tiny 100, like 103 volt. I think it's 3 on the schematic, but they put a 6.3 in the thing. I'm just going to do 125 volt because that's what I have. I don't really have a lower voltage PW 100 microfarad. Now here's where it gets interesting. If you guys follow X-Ray Tony B, he recently-ish did a series of videos just kind of looking at capacitors and just kind of debunking the film capacitor myth that you want a film capacitor in your audio circuit. Kind of supporting the idea that the engineers who designed these amplifiers, particularly the Sansui he was looking at, that's a mid to late 70s model, so like this stuff is well understood and these engineers are able to take these deep dives into understanding stuff. They're designing these circuits around the electrolytic capacitor and making it so that when you use the electrolytic capacitor, that's the ideal state. Like if they wanted a film capacitor, they would have put it there, and it's very evident in the schematic when you look at it closely and objectively. Film capacitors existed. It's not just this new thing that's now affordable. They did exist, though they probably were more expensive. So basically, it's really important what you put in the audio circuit. If I look at this board here, what I see are the black Nippon Chemicons and the gray Elna capacitors, which are generally what I would find in a power circuit on an amplifier of this vintage. But since this is such early Pioneer, I suspect that they didn't quite understand or didn't have the budget or whatever for a, quote, audio grade Elna capacitor, like an orange one. You know, you see the orange ones in later Pioneer stuff, that would be an audio grade capacitor. So they have just general capacitors on this entire board. So I'm kind of left in this interesting position. Like, do I just go ahead and replace those capacitors with a general power capacitor, like an Ichicon PW? Or do I go further and replace it with like a UES bipolar Nichicon or some other audio grade capacitor? Which, by the way, I was on Mauser the other day and I actually bought like a whole bunch of these guys, these UES series, because it's looking like it's about to get a little bit harder to find this stuff. Like as the economy and technology changes, these through-hole electrolytic capacitors are not being used by companies as often anymore in new designs in favor of surface mount components. So, you know, this stuff is probably about to get a little more expensive or a little more specialty. So I bought a whole bunch. Anyways, that's a whole other video that I could make, but I wouldn't know what the hell I'm talking about. Anyways, do I replace these capacitors that I deem to be part of the audio circuit with an Ichicon PW, which looks like it'd be a perfectly suitable replacement based on what's in there right now? Or do I go above and beyond and use an audio grade Nichicon capacitor? I think I'll go audio grade just for funsies. If I notice a huge difference in the sound signature of the amplifier, maybe I'll go back to an Ichicon PW, but I don't really think I'm going to notice much of anything in this thing. And even if I did, it might be a function of, you know, these guys right here replacing your coupling capacitors, which is your last stop essentially for the audio signal. So I don't know. It's an interesting discussion. If you know what you're talking about, or even if you think you know what you're talking about, go ahead and leave a comment with your thoughts if you are bored and feel like sharing them. I did leave a comment on X-Ray Tony B's video. He basically got to this point where he was at a really good situation where he could do a direct comparison of 1 amp with film capacitors in the audio path versus 1 amp with electrolytic capacitors. Because he did a comparison, he has 2 of these preamplifiers. He did a comparison where one was recapped and one was not. And they performed basically identically, which is interesting. So you may expect that an amplifier fitted with the film capacitors versus electrolytic in the audio path would perform differently, because film capacitors, if you've watched this video before that, perform so vastly differently than electrolytic capacitors in many regards. So that is why if you put a film capacitor where an engineer spec'd an electrolytic, you're probably going to change some things and create some scenarios that the engineer didn't want back in that day. Okay, I don't normally rant this much in my videos. I'm starting to sound like an X-Ray Tony B video. Another thing he talked about is the voltage value. That'll change the performance characteristics of the capacitor. Like the 10 microfarad capacitors in here, I think they're 16 volt as your first stop for the audio signal. What I've got is a 10 microfarad 50 volt on here. I don't know. I'm going to throw it in there. I'll see what happens. I really don't know what to expect. It's probably going to sound fine. I forgot to turn my microphone on here, but what I'm showing is how I adapted this new style potentiometer to the old style. So you can see the old one is much bigger. What I did is I took some solid core wire, which means it doesn't have copper strands. It's just one little piece of conductor underneath the insulator, and I used that, cut some little pieces of it. So I used my soldering iron, put little tiny extensions on the leads of this new potentiometer, and then I was able to fit it into the circuit board. So once you get your new pot put together here, you'll want to make sure you have it set to something similar to what the old one was. So the way you do that is you measure at any one side and then the top. Yeah, help if you could read the multimeter. So if you can see right here, looks like, come on, we're at about 20 ohms on this one. So we'll just do the same thing on this pot. We'll measure like so, just like the other one. We're at about 25. We'll make a small adjustment. There, 18 is fine. We're going to set this anyways, but just to get it similar to what it was compared to the old pot. So this thing's not too surprised when you turn it back on. Okay, I've taken care of the power amp board. Don't worry about those. We've got our 4 potentiometers replaced. We have the 12 electrolyte capacitors replaced. And I'll just kind of show you what that looks like here. So there we have our pots, right there and there. No, it could probably be straighter, but whatever. Caps, and then transistor wise, I decided to replace the other 2 SA-484 just so I have SA-940s on both sides. I like to have each side be the same if I can help it. Almost replaced the 2 SC-484s with KSC 2073, but decided against it because it's probably going to work just fine like that. And then I replaced the initial transistors. What is it? 2SC870. I just threw some KSC 1845s in there because why not? Pretty harmless thing to do. So next thing to do is replace the coupling capacitors, which is the 2 right here. I've already removed the one wire for the, looks like this is the positive end that comes on these wires. So these are gone. It's going to be a little more complicated right here because we've got looks like 2 resistors and a bunch of wires too. I'm going to try to think of a easy way to do that that's not so painful. So that's probably going to start with just lopping these off real quick, like so. And then I'll be able to remove the capacitors from this side. It looks like these might be fancy. Yep, they only come out with 1 screw. And, you know, like I said, not the same size. That bugs me. Whatever. Everything will be just fine. Here's a new one so far. So what this is just a cutout piece of a sheet of rubber. And I cut it further so that you can kind of wrap this around most of the way. Not quite all the way, but most of the way. And then we'll have to take this nut and screw completely apart, which is difficult because they used some sort of thread locker on it. But not so bad once you get it off fully the first time. And then I've got the negative lined up with this screw right here, so we'll do the same thing with this one. Just kind of open it up and slide it in there. And then there, that looks to be about the same as the other one. I'll get the rubber, shift it out of the way a little bit. There, that's similar enough. And then we'll put our screw back through, get the nut started. I'm able to do this with my fingers holding the nut, which is nice. Not quite to the end there, so get our tool back out. Something like that. Doesn't need to be super tight. You just clamp it on rubber. And there you go. Next, we will consider putting some ring terminals on the ends of these, since they're just the silly snap-in style that don't work so well with our old application here, which wants a solder tab, kind of like this, so you could loop your wire through and just solder it. We don't get that luxury in today's repair. So for the positive end, we're just going to have the one wire coming off of the amplifier. That's not going to be hard. We'll just solder the one wire to the positive lead on each one. The negative, though, that's going to be interesting. Okay, I think I have a plan. I think what I'll do is I'll desolder each of these tabs that I left so that I can see the hole where everything's wrapped around. I'll run a new wire through that comes down to my new capacitor, and I'll just wrap each wire around. I won't need to use ring terminals. Alright, so now that the caps are in, what I'm going to do is I'm going to take the wires and I'll just kind of wrap them around the terminals here. So there's one, and yeah, it just fell. Don't worry about it. And then here's my new wire. So yeah, there's those two. We'll give the yellow one a little pinch, since I didn't get that one very tight. A little pinch with the pliers to get some mechanical strength is never a bad thing. Sorry. Now let's bring in our soldering iron and do the thing. There's one. And there's two. Can I show that any better what I just did? Not really. We're working with a tripod here, folks. Alright, there you have it. Coupling capacitors replaced. Yep, so here's what I see. This is the tab that I cut off of the old capacitor and left it in place, added a wire, ran it down to my negative, did the same thing over here, and then I've got my positives connected. It's just one wire. And then of course the rubber keeps them pretty solidly in there. Let's see how they look up top. Yeah, you wouldn't really think much of that if you didn't know what to look for. So that's great. Next thing we got to do is mica insulators on the output transistors. Again, I've done this on camera so many times, but you know, it always makes for a good time lapse, and it's always fun to just talk about it. Okay, these are the old ones. We don't want them. They go bye-bye. We take our Dow 340. I might just buy a new one. This thing is getting so... I've had this for years. Okay. Let's mix that up. First thing we do is get the insulator. And once we do that, put some on the actual output transistor. Again, very light coating. You gotta try not to touch those emitter and base pins, because we don't want this on our electrical connection. Then what we'll do is we'll take our insulator. We only did one side. We're going to take the dry side. We're going to put it on the transistor. So we have the wet side exposed, and then this wet side will just kind of sit on our heatsink like so. We'll put it in like that. And the reason we do it this way is, look at that. If I touch that insulator, it doesn't have any compound on it because we have the wet side on the heatsink, and then the transistor is wet, so you have two layers there. And we'll just do that 3 more times. And yeah, just FYI, there is a product out there that you can buy that is basically a drop-in insulator pad, essentially. But they cost more money. I looked at buying them one time. They're like $1 a piece or something. And then I looked at these good old classic insulators, and they were like a couple cents a piece. So yeah, the price break was significant enough for me. I don't mind doing this too much. It does take a little bit of time, but it doesn't take that much time really. Those are in, and now that we've got the compound, they'll actually stay on. It's kind of sticky. Oh no, we've already lost one transistor. We'll just have to put it back. Oh, geez, and they're very slippery. Like, you'd think you'd be able to grip it like this. And yeah, I just did successfully there, but like, that's not always how it goes. Okay. I guess it's worth noting, these are 180 degrees from one another. So, like, I tried to put them all in the same way, and you saw me take this one back out and flip it upside down. The holes are drilled such that they go in differently. We'll need some compound for our temperature sensing diodes, so I'll just get that done right now. If I wanted to be cleaner about this, I'd put it on the actual diode, but that's just what I did in this moment here. Okay, how the F do you put this back together? That is the question. Okay, big moment. Let's see. You see the melt? Yep. Did I do it right? I did something right. Okay. Let's hook our speakers back up. And just a reminder, the speakers are so messed up. Like, I have all these jumpers and stuff here because of the Pioneer proprietary stuff, you know. There's not actual speaker connectors on this thing. Oh, I hooked it up to B speakers. That's why nothing's happening. Hey, that sounds great. Nice sound out of both channels. It actually sounds really nice. That's good stuff right there. I like that. That was a lot of work. Okay, so at this point, I think what's left to do is some adjustments for the amplifier. Make sure our bias is good, make sure the other thing is good, especially since we replaced all the pots. I'll do that tomorrow. It's approaching midnight. Alright, so the documentation on Hi-Fi Engine doesn't actually have anything talking about like how to actually set this thing, but based on what I know, I think to set the bias we're going to measure across an emitter resistor, and I'll show you what I'm going to do. You can see in the power amp board, we've got the emitter resistors. They're those big white chunky guys that are coming off of the output transistors. We're going to measure across the outside ones to ground. Because when I measure across the inside ones to ground, you get basically half the rail voltage. So what we're going to do is we're going to take our one probe. We'll just, ground is anywhere really. And then I've got my handy little screwdriver to turn our new bias pots that are at the very bottom. You can kind of see those. Well, can you see it? Yeah, there's one. That blue square with the white circle in it. Those are our new bias pots. That's what we're going to turn to get this to happen. So, if I take my thing and I go right here, somebody in the forum says we want 10 millivolts, and I've already done it, but I'm just showing you, what I'm going to do to do that if you're following along at home. I think this is right, and I'll show you why I think it's right. It's because, maybe you can see this, I don't know. If I turn this pot, I can get this to go all the way up to like 50 millivolts. And if I turn it all the way down, I can get it to go to 0. And when I found these in here after running the amplifier a little bit, the amp was running very cool, which is, what I would expect with a bias of about 10. I think this one was at 8, and then the one up here, it was at 3. So we can see we've creeped up to 12 as we've warmed up. So let's tone that down a little bit. There we are at 10 again. And now the clipping adjustment, that's going to be the bottom pots down there. In the forums, everyone says that you're supposed to bring it up to 100K to get it to be a symmetrical clipping. Unfortunately, I ordered a 50K and I don't have 100K. I don't feel like modifying this, so I just want to see what happens when we actually try to get symmetrical clipping. So at this point we've got the bias set. Now it's time to get out the oscilloscope and actually take a look at what is going on with the symmetrical clipping thing. Okay, this is just an absolute mess right now. Because I've got it connected all crazy because of the lack of actual speaker terminals. That is something that the customer is going to do themselves later. I would do that in this video, but that's just not something we have right now. Okay, so it's actually the first time I have this thing off of the dim bulb, so that's kind of cool. I have our tone playing here. The volume's up high, and let's see. Okay, nothing was happening on the scope because I didn't have it plugged in. Okay, now I've got the scope hooked up, and let's bring this up a little bit. Okay, we don't have, okay, there's our waveform. That looks good there. Now let's bring it up to clipping. Okay, as you can see, we have extremely asymmetrical clipping right now. So what that means is we need to adjust that potentiometer that we replaced and see if we can get symmetrical clipping. Okay, well, when I turn it, I can get it to at least not clip up there. I can get that top waveform to not clip, but I can't get anything out of the bottom waveform. So I don't really know what's up with that. So that is wrong. Why would that happen? Well, let's see if the same thing is happening on the other channel. Okay, so on the other channel, we appear to be in much better shape here. So let me rotate this pot and see what we get. Okay, so see, this is more like what we're wanting to see. I can actually get a symmetrical clipping situation on this side. If I rotate this one up, I can bring it into clipping down there. See down there, I've got the clipping, and then if I rotate it the other way, I can bring the clipping to the other side. So that is what we're wanting. So I think I've got that pretty symmetrical, and looks like we're putting out 23 volts AC, So let's throw that into the calculator and see what that is. So that is 66 watts per channel on the channel that's working. So that's pretty interesting that one channel is working better than the other. So there must be something else on this board that is not quite right. Oh, that heatsink is quite hot right now. So I've been working this thing hard. Okay, it's getting a little interesting here. To address that weird clipping, I'll put the schematic on the screen. You can actually put a resistor in front of that trimmer pot, so you don't actually need to upgrade to a 100K pot. You can just kind of change the value of that resistor, then you have 50K of range per se. Luckily, that resistor is really easy to get to. I was able to kind of put something in place of it. I put an 800K resistor right there. And that's basically throttling what's coming to that pot, so we can have more adjustment in the voltage. So it used to be 100K, now it's 800K or 820, and look what happens. Our clipping went completely to the top instead of the bottom. So now, instead of 100K, so we had 100K, I'm going to try 180K. Let's see if that changes anything. It just might, you know. Okay, so now that's haphazardly on there. Let's turn back on and let's see what our clipping looks like now. See, now that looks like something we could potentially work with. Let's try that. Let's try working with that and see if we can get that symmetrical clipping with our 50K pot. So yeah, there it is on top. I can get it to go away on top. I can get it to go away, actually. That's pretty nifty. So that right there I'd actually call symmetrical. It's happening at the same time on the top and bottom. However, there's a caveat to that. I don't think we are getting the same power out of each channel. So if I go, so that's where clipping starts right there. If I switch to the other channel, you see, look how much higher we can go with the other channel. So I got my symmetrical clipping, but one channel is way stronger than the other. So that's really bizarre to me, and I don't like that fix very much. The only other thing that I did on the good side, the more powerful side, is I replaced that one resistor that was fried. And I checked, and there's similar values in the amp. I mean, the one that I didn't replace versus the one that I replaced on the other side. So I don't really know what to think right now. This is very bizarre. Okay, I've made an important discovery. You know, you always want to think about, you know, what is actually going into the power amp? Like, could this be coming from another place? So that's what I looked at here. So I thought, okay, maybe we should check what's going on at the preamp. So I will show you here what's happening at the right channel. You know, that's what we want to see. That's perfect. But at the left channel, let's look at that again. Hey, would you look at that? There's that clipping we saw in the power amp. So it's no wonder we couldn't get symmetrical clipping. There's something terrible happening in the preamplifier. So now we need to take a look at the preamplifier. I don't know what exactly would cause this, whether it's a transistor, a capacitor, or a resistor. So I'm going to take a moment and take a little deep dive into the preamplifier and see if I notice anything strange between the channels. Okay, I may have found it. So I'll put up the schematic. I tracked down that it's happening at the filter amp or whatever this board, and if you follow the signal, like here's the input. I'll bring this up. That's what it looks like at the input. You know, very good. That's exactly what we want. If you go past that first capacitor, you know, same thing, still happening. But then you cross over to that resistor, you come to the transistor, so like at the, what is it? Alright, so basically when you get to that transistor, it's all fine, but then you get to the other side of that transistor and it's completely clipped off on the bottom there. And if we look at that same transistor on the other side, I would expect that to not be clipped off like that. And you go at it, no clipping. So that's where the issue appears to begin. So I'm going to try replacing that one transistor and see what happens. So what we currently have loaded in there is a 2SC870. So what I will do is replace it with a KSC1845. Perfect. Okay, I'll slide this guy back into the little securing tab there. Nifty. Okay. Let's try this again. Let's see what we've got going on here. So if we recall, we had the weird waveform here, and now it's still there. Okay, so it's not that transistor. So we gotta look elsewhere. What the heck could be causing that? That's really bizarre. Alright. This capacitor that's bent down right now, that one right there. If I looked at the signal on both ends of it, the signal looked good. But I just checked voltages on the transistors, you know, this one versus this one, and this is around like 10 volts at the emitter, and this is like 22 volts at the emitter. So I was going to pull a resistor to see, you know, like what's happening here, but I accidentally pulled the leg for this capacitor instead of this resistor. So I just tested it anyways, just in case, just to see what would happen if I tried it with this capacitor's leg pulled, and the voltages reverted to what they were on this transistor. This is the good side right here. So this is a 1 microfarad 25 volt capacitor. We're going to try replacing that real quick. Let's pull this out. Let's go ahead and test this capacitor real quick. Let's see how this capacitor tests, because if this is indeed a bad capacitor, we should get something wild going on here. So let's see. I mean, 17 ohms is a fairly high ESR, but let's see what this one measures at. Okay, the new cap measures at way less ESR. That's 17 ohms versus 3, and yes, this is a 50 volt capacitor, and that one's a 25 volt, but that's a big difference. So let's throw this in here, see if we get a change in behavior. Okay, new cap is in. Let's check our voltages here, because we know we saw like 23 volts up here. Yeah, so up there we have 22.7 at the base, and now here at this base we have 23 volts. So we may have gotten it. This capacitor's ESR might have been so high that it was pulling this voltage down from 23 to 10. That's not good. So okay. Let's see if we have anything different at the output now. Okay, so I'll show you the good channel. This one was always working. Very good. And now let's go to the one that was not working, the quote bad channel. Fixed it. There you go. I don't know exactly how electrically in the circuit it would manage to do that, other than this thing's ESR being at like 17 ohms. Let's pull the other one from the other channel and see if it's a comparable amount of ESR on that one. And if it's like way less, then we know that that was, at least with our test equipment here today, that would tell us why that was happening. Okay, this one only has 7.5 ohms ESR, so there's your answer. This capacitor is bad. And you can, I don't know if it's from the manufacturing process, but this one's bulging a little bit underneath, but it's this epoxy style fill, so I don't know what exactly that means. And yeah, again, there's that 17 ohm ESR. That's way too high. So I guess in this situation, this supports the idea of recapping. So now that I have that one out, I'm just going to replace it. So I think what I'll do actually is I'll put this transistor back so we have them all the same, and I think I'm just going to recap the preamplifier, because I see there's 8 total of those 1 microfarad 25 volt capacitors, so I think those should all be replaced. I'll even replace this big one while I'm in there. This one smooths power from the power supply. And yeah, I'm glad I found that. That was a good find. Yeah, I've got all the capacitors replaced. Yeah, so these all tested. The capacitance was pretty much okay, but I found 2 or 3 that were at like 11, for example. And none of them were quite as bad as the one that was causing our issues at 17. But you know, I think it's good that we got rid of all of those. And if you're curious, this 100 is measuring at 155. That's pretty high. And that ESR should be lower than 0.1. And then I switched to these bipolar Nichicon audio grades because I ran out of Silmic 2s for the 1 microfarad. So just out of curiosity, what does a new Nichicon bipolar test at? We get 2.9 ohms and then, you know, dead on capacitance. So that's a lot better than what these guys were doing. I think we're going to be much better off now. And yes, I do still need to solder this, so I'll do that real quick. And then we're going to see you back at the oscilloscope with our final power test and getting the centering adjusted properly on our questionable channel, which is no longer questionable. Channel 1 is going to the right channel, so we should get the symmetrical clipping like we were seeing. It is still symmetric. And now channel 2. This is the left channel where we got the bad stuff, and now we're actually quite good. So let's go in. Let's adjust for symmetric clipping by turning that pot. Okay, so what I'll do is I'll bring it up to where I see the first amount of clipping, and I want to turn it so I take that away. And when I do that, I kind of bring it to the bottom there. Okay, that looks pretty good to me. And then for volts AC, we're at 23 on the 23 volts AC on the right channel, which is this one. We were getting like 24 earlier too, after we really warmed this thing up. They're clipping at very similar things, so yeah. We are achieving the published, I believe, 60 watts per channel on this amplifier, and with that, I think we are done. How about we hook the speakers back up and celebrate by listening to everyone's favorite song. There it is. Well, this thing sounds pretty good. That was a pretty interesting adventure we went on, figuring out that weird waveform and having it be in the preamplifier, but made for really good content, I suppose. As I play with this a little bit more, I hear some dirty controls, so I'll go through and do that, but I'm not really going to put that in the video because We're probably at about an hour at this point. So that is it. Thank you so much for watching. I hope you enjoyed this, and I will see you in the next one.